Alright, so our goal today is to talk about what's called integration by parts. It's when you have two functions being multiplied and they don't work nicely together in terms of simplifying by use substitution or some other method. Okay? So we're going to call them two things. We're going to talk about this one, we're going to talk about this one. Two different colors. I'm going to use two different colors to do that. Integrating f of x times g of x. Here's what I'm going to talk about. We're talking about the derivative of a product. So the first thing that I'm talking about is I'm going to say let u equal f of x. And then I'm going to say let v equal g of x. Alright? Now, these are two generic letters, y, u, and v. That's the way that it's usually been taught. Could you use other letters? Yes, but they just use u and v. So if you agree with me, we're going to talk about I'm sorry, wrote that wrong. U times v is equal to f of x and g of x. Hopefully everyone's okay with that. So let's talk about taking the derivative. And I'm going to talk about taking the derivative of f of x times g of x. So that means I'm taking the derivative of u times v. What that means is that I have u, sorry guys, u times v prime plus u prime times v. Integration. I'm going to real quick do this so that I get my, for some reason it's not oriented. 1 second. So here we go. Which means that I have v dx plus du dx times v. Hopefully that would make sense to you in terms of what we have. Now, we're going to talk about putting this all together. And we're going to talk about integrating both sides. And what I mean by integrating both sides is I have this. I'm integrating the derivative of f of x, g of x. And I'm integrating u times dv dx plus du dx times v dx. Okay. Now, let's talk about what that's going to give me. This left-hand side, integration and derivatives to cancel each other out. We're left with f of x, g of x. This right-hand side, I'm going to split into two separate pieces. Because it needs to be two separate pieces because I've got multiple things going on. So, integration of u times du dv dx, but there's a dx on that piece. And then plus the integration of du dx times v, and that also has a dx. So they both get dx's because I just separated into two separate pieces. I'm still going to be working on this right-hand side because this looks really weird. I want to clean it up. What I need to know is I have a dx divided by dx is a good way. So it's the integration of u times dv plus, notice that these cancel out, the integration of v du is equal to this f of x. Oh, but I'm going to change this so everything's now in u's and v's. This was u times v. I'm going to move things around so I only have one integral on one side. So I'm actually going to move. I am going to move this to the other side. v du to the other side. So I have u times v minus the integration of v du equals the integration of u dv. You'll notice, ladies and gentlemen, it still looks very weird. This is actually what we call integration by parts. And this right here is the equation for integration by parts. I abbreviate IBT, integration by parts. So, and if you notice, I'm going to go flip to the next page. If u equals f of x and v equals d of x, as we just said, then the integration of u dv, meaning that I have, what this all means, is I have an original function, and I have the derivative of a function. That's what I'm saying to you. I have an original function, and I have a derivative of a function. Right? I have an original function, and I have the derivative of a function, g prime. And it still looks really weird, and I get that. And if you're evaluating, this is the UV. You can evaluate straight shot. It's already been integrated, and then you actually have to integrate this piece. All right. Again, I know it looks really weird, but let's talk about it together. And here's my first example. X cosine x dx. There's no u substitution that you can do. There's no simplifying. There's no manipulating. It can't be done. So we're going to use integration by parts to do this. So here's what I'm going to write. I'm going to write this out to remind ourselves what it is. This is what was done up top. U dv equals u times v minus the integration of v du. And here's what you're going to remind yourself. What is going to be easier to take the derivative of, and what's going to be easier to take the integral of. That's how you're going to decide which one's which. What's easier to take the derivative of, and what's easier to take the integral of. And sometimes one is easier than the other. And sometimes they both work and sometimes they don't. And I'll show you for this one, actually. I'll show you on this one how they both don't work. So here we go. Here's my first one. And hopefully you recognize that derivative of x is actually easier than integrating it. So I'm going to say, let u equal x. Then du is 1 dx. So, that means that this is dv. dv is cosine x dx. So the integral of cosine x dx, the antiderivative of cosine x, is negative sine x. Now I do not need to do a plus c. Plus c's come at the very, very end. Oh, nope, I did that wrong because the derivative of sine is cosine. It's not negative, it's just positive. Sorry about that. As soon as I wrote that down, I knew I was wrong. We're going to follow the green formula up top. So it is uv, so u times v minus the integration of v du. I'm going to simplify this. I don't have to do this, but sometimes it's just easier. So this is x sine x minus the integration 1 times dx times sine x is just sine x dx. You don't have to write the black. I did it so you can see the simplified version of what's in the multicolors. I can integrate sine x dx. That's actually easy to integrate. This x sine x is staying minus equals. The integration of sine is negative cosine. So plus cosine x and plus c. That, ladies and gentlemen, is my final answer. That is what the integration of sine x cosine x, or the integration of x cosine x is equal to. Integration of x cosine x dx. That's what that is. That's the integration. Now some of you are wondering, could I just flip them around? Could I do the other two pieces? Alright, I'm going to try that. So I'm going to say let u equal cosine x, then du du is negative sine x dx. And then I'm going to say dv is equal to x, then v is x squared over 2. This is x dx. This is x squared over 2. So think about this. If I do this, then I'm saying it's u v minus the integration of v du. Ladies and gentlemen, this piece right here is not going to be easy to integrate. This was not the way to go, because it shouldn't be that it's hard to integrate. So that did not work for me. Nope. That was not the right way. I would try it the other way, which we did the first way, and the first way works nicely. If it doesn't work nicely, then try flip-flopping it and see if that'll work. Alright. Number 2. Natural log of x. We've done the natural log of x in terms of, hey, the natural log of x has a derivative. We've never actually integrated natural log of x. That's because there's not a nice integration, but I can find it now. And here's how it's going to work. We're going to do it again. Let u equal something, but you're like, Miss Jira, there's only natural log of x. There's no other term. Technically, you have a 1 dx. So if I say let u equal natural log of x, I'm going to say v equals 1 dx. And again, the integration of u dv, I'm sorry, I wrote that wrong. This is dv, not u. U dv is equal to u v minus the integration of v du. And again, that's that same formula that I have sitting over here. Alright, so we got this. Let's see if this will work. If I say that u is natural log of x, then du is 1 over x dx. If I said that dv is 1 dx, that takes care of that dx. That means that v is just 1 over x. Integration. One side is deriving, the other side is integrating. So, u, natural log of x, v, x, minus the integration of v, x, du, 1 over x dx. You'll notice I say it out loud every single time so you can see what I'm writing. I am going to simplify this because I can. This just becomes x natural log of x. It does not become the natural log of x squared because that x is sitting outside the natural log. These just go to 1, so you're integrating integrating 1. So my final answer, the integration of the natural log of x, is equal to x natural log of x minus x plus c. The derivative of 1, or the integration of 1 is x. There's my final answer for that one. Alright. We're going to get a little more complicated. And here we go. Number 3 says the integration of x cubed e to the x dx. And again, not really nice, but we can do this. The derivative of e to the x is e to the x. The integration of e to the x is e to the x. So that can go either way, but it's going to be easier to derive x cubed than it is to integrate x cubed. So we're going to derive it. So we're going to say u equals x cubed, then dv equals e to the x dx. So du is equal to 3x squared dx. V is equal to e to the x dx. Hopefully everyone's okay with that. And again, u dv is equal to uv minus the integration of v du. Same formula all the way up there. Alright, now I'm going to put everything together. So, equals u v. Oh, I put a dx there, it shouldn't have been there. V minus the integration of v du. Here's an issue. This right here, still can't integrate that. Still has an issue integrating that. What I can do is I can do integration by parts again. Again, I'm going to let u equal the 3x squared. Then du is 6x dx. dv is still going to be e to the x dx. And v is equal to e to the x. You can use integration by parts multiple times until you can integrate that one piece that you need to integrate. So we're going to do this multiple times, just an FYI. So I have x cubed e to the x, that's from above, minus, because there's a minus sign before that integration. It was u v minus the integration of v du. So, here's the issue. First two pieces are okay, the third piece, I still can't integrate that third piece. Still can't integrate that third piece. So again, I still have to do integration by parts with this. Now, everyone asked me, has also asked me, could you have pulled out the 3 in the front? Sure, you could have. I just didn't. I just left it the way it is. That is up to you. And again, let u equal 6x, then du is 6 dx, and dv is e to the x. That means that v is e to the x. E to the x dx. Taking care of all those pieces in there. This x cubed e to the x is okay. I have a minus 3x squared e to the x, and then I have a plus. Now I'm doing the integration of the underlined piece, of the underlined yellow piece, which is going to be u v minus the integration of v du. Oh, now I've gotten down to this, and that can actually be integrated. Yes, this is taking some steps. This is going to take some paper. So now I'm going to simplify. I have x cubed e to the x minus 3x squared e to the x plus 6x e to the x minus, now I can integrate this, that's just a 6 that's hanging out, comes e to the x, and now I can put my plus c. And I am finally finished. It's got a lot of pieces to it. It has got a whole lot of pieces to it. And that was painful. I'm going to show you another way to do this same problem. Now, this way that I'm going to show you does not work for everything that we do. It only works when you have a polynomial as one of your two functions. That's the only way this next method works, is if you have a polynomial for one of the two functions. So again, I started off with x cubed e to the x dx. That's what I'm integrating. Now, this is what I call the tic-tac-toe method. You'll see why in a second. Only works when one of the functions is a polynomial. That goes to 0. That derives, I should say, that derives to 0. If you have one that's not a polynomial, if it's a polynomial that doesn't derive to 0, well, it's not a polynomial, but it has to derive to 0. You have to be able to get u prime as you keep doing u. It has to go down to 0. So here's how the tic-tac-toe method works. We're going to draw 3 columns. The first one we're going to put a plus or minus. The second one is going to be u, and the third one is going to be dv. We're going to ignore the first column right now. We're going to just deal with the second and third column. The first column is u. That would be x cubed. The second column is dv. That would be e to the x dx. That middle column with the u, we're going to derive. You're going to derive till you get to 0. Literally. We're going to derive till we get to 0. So it's 3x squared, and then 6x, and then 6, 0. You must derive until you get to 0. 0 is where you're stopping. On the right-hand side, we are integrating. We're going to integrate e to the x dx. The integration, this is a nice one because the integration of e to the x is e to the x. The integration of e to the x is e to the x again. So this is integrate. This is derive. And this is e to the x. And this is e to the x. Now, the first column here is plus or minus. You're just going to start at plus, and you're just going to keep on going down. And alternating sides. So plus, minus, plus, minus, plus. And now I'm sure you're thinking, where in the world are you talking about tic-tac-toe? Because it really doesn't look like a tic-tac-toe board. What are you talking about? And I'm going to use a highlighter to show you what I'm talking about. Here's how this is going to work. You are literally crossing out things, because that's what you do in tic-tac-toe. You cross out diagonals, right? You go either straight up, down, left, right, or diagonal. We're going to do that, but we're going to go 2 across and diagonal. And then we're going to go 2 across and diagonal. We're going to go 2 across and diagonal, 2 across and diagonal. And you do it until you have no more pieces to go, which is where I stopped right here, because 0 is the last one. You won't use 0. The things that are highlighted are going to be multiplied together. So again, the things that are highlighted are going to be multiplied together. So I have a positive x cubed e to the x. I have a negative 3x squared e to the x. I have a positive 6x e to the x. I have a negative 6 e to the x. Ladies and gentlemen, put an equal sign and a plus c. And that is the exact same answer you had when we did it with integration by parts the long way. So you can do these multiple ways. So I'm going to do another example. I'm going to add an example because I think some of you, we want to practice tic-tac-toe again. But this time I'm going to put some numbers on here. I'm going to go from 0 to 2, and I'm going to make it e to the 4x. I'm sorry, I wrote that wrong. I'm going to make it x to the 4th, e to the 2x, dx. Why don't you see if you can set up the tic-tac-toe board? Or at least I'll start with you. So here we go. Top, first column is plus or minus. Second column is u. Third column is dv. Don't touch the first column is the last thing you do. Second column is u. That must be your polynomial that goes to 0. If it's not a polynomial, then you cannot do this. It has to be a polynomial that goes to 0 because you have to have a stopping point. So, x to the 4th, 4x cubed, 12x squared, 6x, not 6x, 24x, 24, and finally 0. The right-hand column is my dv. It's the one that you're going to integrate. Okay? So, again, middle column is derive. Last column is integrate. Alright, here we go. I'm going to integrate e to the 2x dx. That is not just e to the 2x because that x is not a plan of x. Technically, you have to do substitution. And you should recognize that I need a 1/2 in front. That's the integration of e to the 2x is 1/2 e to the 2x. I'm integrating that again. So again, I need another 1/2 in front. So it becomes 1/4 e to the 2x. I need another 1/2 in front. 1/8 e to the 2x. And then it's 1/16 e to the 2x. And then it's 1/32 e to the 2x. So here comes, ooh, I'm not done, I can't do my highlights yet, because I still have to go over here. Positive, negative, positive, negative, positive, negative. Here comes my highlighting for my tic-tac-toe. First two, diagonal. 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 And I can't go anymore because there are no more spots to go. I'm literally just multiplying the things that are diagonals, I'm multiplying together. So I have a positive x to the fourth times 1/2 e to the 2x. I have a negative 4x cubed times the 1/4 e to the 2x. I have a positive 12x squared times the 1/8 e to the 2x. I have a negative 24x times the 1/16 e to the 2x. I have a positive 24 times 1/32 e to the 2x. I'm going to clean this up a little bit, just to make it a little bit easier to deal with. 1/2 x to the fourth e to the 2x minus my fourths cancel out, x cubed e to the 2x plus 4 goes into both 12 and 8, makes this 4, nope, 4 goes into it, makes it 3/2 x squared e to the 2x minus 24 and 16 both have 8, so 2, 3 x e to the 2x, and then plus 24 and 16, or 24 of 8. 8, 3, and 4, and there's no x, it's just e to the 2x. And now this is evaluated from 0, what did I say? 0 to 2. But notice that that's a lot more cleaned up and a lot easier than having to do integration by parts 17 times. Now some of you are like, hey, can't you just take on e to the 2x? Because I do all have e to the 2x. And I can. If that's something that you want to do, you totally can. And actually I think I'll do that. So e to the 2 times 2. And then it's going to be 1/2, 2 squared. Nope, 2 to the fourth. Minus 2 cubed plus 3/2 times 2 squared minus 3/2 times 2 plus 3/4. That's the first one, and now 0. So minus 1/2 times 0 minus 0 plus 0 squared minus 0. And that one didn't have anything. So the zeros go away. It's kind of nice. So this is e to the fourth. Now that is 8 minus 8 plus this is 6. That's a 2 cancel out. And this is minus 3 plus 3/4. That's actually less than I thought. Those cancel out 6 minus 3, so it becomes 3 plus 3/4. E to the fourth. Oh, you know what I did forget? When I took out that e to the fourth. Oh, I was 0. I think I made a mistake, and so just need to make sure that I didn't. 0. Ah! Here's what I didn't do. I didn't put in e to the 0. Right here. Minus e to the 0. I was like, there's a mistake. These are all zeros. All of these are zeros, except for the last one. I still have this 3/4. There we go. So this has a minus 3/4 because e to the 0 is 1. It's like, there is something wrong. Oh, I found it. What happens when you mix 6 up? 9/4, so that's 9 is 12, so that's 15/4. 15 fourths e to the fourth minus 3 fourths. And there, ladies and gentlemen, is my final answer. Oh, nope. Nope, still made a mistake. That is negative 3. Does not make this this. This makes this negative 9 over 4. No, it's positive 3. Oh, good God. Miss Zero. Miss Zero screwed herself up again. No, it's positive. It's positive. It's 15 over 4. Alright. We're going to do 2 more. Here we go. Yep, away. Here's this one. This one says e to the x cosine x. And I cannot, neither of these are polynomials, so you can't just go down and leave them. That doesn't work that way. It's just a bummer. So that means that I gotta do some other math. So let's talk about what I can do. So I'm gonna let u equal cosine x. And the only reason I say that is because it's easier to derive cosine than it is to integrate. It actually doesn't matter, you can do it either way, because the derivative and integration of e are the same. So du equals negative sine x dx, and I have dv equaling e to the x dx, and then v equals e to the x. And again, they can go either way. This one actually does not matter. I just think it's easier to derive than it is for me to integrate a trig function, because I know those more. I'm more used to doing those. So I'm going to derive my trig function and integrate my e's. Alright, so here we go. U v minus the integration of v du. Now I have an issue of how I just wrote this, and hopefully you recognize what issue I have with what I just wrote. What issue I have is because right now inside the integral it says e to the x minus sine x and not e to the x times negative sine x. Parentheses do matter, so those parentheses do matter right there. I'm going to clean this up before I try and do anything else, because it's just easier. I'm going to put e to the x in front, that way I don't have to worry about it. And then minus, and this becomes plus, this is why I cleaned it up, plus e to the x sine x dx. Huh. I gotta do that again on this. I gotta do integration by parts again. So again, I'm gonna do u equals sine x, then du is equal to cosine x dx. And I'm gonna say dv is equal to e to the x dx, v is equal to e to the x. So e to the x cosine x is just hanging out. And now I've got u and u. V minus the integration of v du. I'm going to clean it up so I don't have all the parentheses. Again, you'll notice I do like to do some cleanup stuff. Just makes it easier sometimes to see some stuff. And I'm sure some of you are going, well, I'm going to repeat doing this over and over again, and that's not going to go away, Miss Jero. So what do you expect us to do? Because it's not going to go away. And I agree. Except, I want you to think about what we actually started with. What did we actually start with? We started with asking you to find the integration of e to the x cosine x dx. Maybe you see something. Did I see anything? If I see something, I mean, do you see that this is that integration and it's a subtraction, so you know what I can do? I can add this integration to the other side because it's the exact same integration. I'm going to add this integration to the other side, which gives me not one, but two integrations of e to the x cosine x dx is equal to e to the x cosine x plus e to the x sine x. And I don't have an integration over here. No, but I can actually solve for the integration because I can divide both sides by 2. So this is a lot like day 1 where we did some manipulation. That's very much what this one was. E to the x cosine x dx equals e to the x cosine x plus e to the x sine x all over 2. Now I have a plus c. Because your final step should have a plus c. Hey look, I've solved for the integration. I've got the integration by itself. That's a fun one because it's not what you expect it to do. Alright, we're going to do one more. And I'm going to do number 6. I'll flip over to number 6. I'm going to skip that one. I'm going to do number 6. And I have a question for you for doing number 6. Because now I've got numbers up here. But here's my question. Can I use tic-tac-toe or not? Because I will always try. If I can use it, I will try and use it. And the answer to this is yes, I can use tic-tac-toe because I have an x. That's a polynomial. So I'm going to use tic-tac-toe. Plus or minus u dv. And here goes my u. So we're saying let u equal x. And then dv is equal to cosine x dx. Cosine x dx. I'm deriving the middle column. That's really easy. I'm integrating this column. So the integration of cosine is sine. The integration of sine is negative cosine. The derivative of cosine is negative sine. Alright? And again, over here, it is just plus or minus until you're in. I'm always going to highlight so you can see what I've done. 2 across, diagonal. 2 across, diagonal. There's my tic-tac-toe piece. So here we go. I've got x sine x minus, well, minus 1 times negative cosine x. I'm going to evaluate this from 0 to 1. I'm going to simplify this a little bit. X sine x, you could have skipped the red and gone straight to the black. I would have been fine with that. I just put it there so you can see everything. Now that's really easy to integrate, to solve. 1, sine of 1. No, sorry, it's not 1. It's pi over 3. Sorry, my fault. Why is it 1? Pi over 3. Pi over 3. Let's fix this. So this is pi over 3 sine of pi over 3 plus the cosine of pi over 3 minus 0 sine of 0 plus the cosine of 0. Don't forget the 0 on trig functions because sometimes it needs a value. The sine of pi over 3, yes, you should know your trig functions. That is square root of 3 over 2. The cosine of pi over 3 is 1/2 minus, that is 0. The cosine of 0 is 1. So I have the final answer being pi square root of 3 over 6 minus 1/2. And there's my final answer. Your homework is in WebAssign. You do need to make sure you do upload your work. Thank you for watching. We'll do more of them when I come back next class. Not next class, in 2 classes.